Okay, so we're going to begin chapter 3, the derivative chapter, with the definition of derivative. We always need to equate the derivative to mean the slope of the tangent line. The slope of the curve is the slope of the tangent line, which is the derivative. And we have a couple different forms of the derivative. The first one is that f prime at a, and I emphasize that. The derivative of f at a number, call it a, is the limit as h approaches 0 of f at a plus h minus f at a all over h. Okay? So, notationally speaking, if this were a 3 in there, this would represent the derivative of this function. It's the derivative of this function, which would be f prime, at this number, say 3. If this were a pi inside of there, this would be the derivative of that function, which is f prime, at pi. Now, no matter what letter we call this, if this was supposedly s at a plus h minus s of a, then this would mean notationally s prime at a. If this were a t inside, this would represent the derivative of this function, s prime at t. Okay? So first, let's focus on using the definition to find the derivative at a point. So if your function is f of x equals, say, 2 over x plus 1, and the a value is, say, 3. Using the definition, find f prime at a. Well, that would be equal to the limit as h approaches 0 of f at 3 plus h minus f at 3 all over h. So replace x with 3 plus h and get 2 over 3 plus h plus 1 minus f at 3, putting 3 into there, is 2 over 4, or 1/2, all over h. And we do need the limit in front of that. You can combine like terms. 3 and 1 gives you 4. So, it's a limit problem. The derivative the definition of derivative is a limit problem. But when we put 0 in for h, we get 0 over 0, which means more work. So I'm going to get a common denominator. 2 times 2 is 4, minus 4 minus h, all over the bottoms multiplied, invert and multiply. And it's the limit as h goes to 0. The 4s will divide out, cross out to give you 0. These divide out to give you negative 1, and when h goes to 0, I'll get negative 1/8. So what does that mean? This answer is actually f prime at 3. This means from the notation, the slope of the tangent line at 3 is negative 1/8. And it should not surprise us because we have enough knowledge to graph this basic function. At negative 1, there is a vertical asymptote. If we take the limit to positive and negative infinity, we would have a horizontal at y equals 0. If x is 0, y would be 2, and we'd get this kind of graph from the left and the right. When we go out to the number 3 on here, and draw a tangent line, notice that it's a very weak negative slope. And that's what that slope is. It's a weak negative slope of negative 1/8. If I want the tangent line, actually, I need a slope and a point. So the x value is 3. The y value is found by taking x, putting it into the function, and I would get 2 over 4, or 1/2. The slope of the tangent at 3 is negative 1/8. So the tangent line setup would be y minus 1/2 over x minus 3 equals negative 1/8. You can cross multiply and get 8y minus 16 4 equals negative x plus 3. 8y equals negative x plus 7. Divide, and you'd get negative 1/8 x plus 7 over 8. That's my tangent line. The normal line is the line perpendicular to the tangent line. So the normal line would have the same setup except for the slope. The normal line would be y minus a half over x minus 3 equals 8, because that's the negative reciprocal of that. Okay? We need to understand what this means also notationally. This is not f prime of a. This is f prime at 3. If I had the a here, then this would have been f prime at a. Okay? All right, so that's the first form. The next one is known as the alternate form for derivative. And it is f prime of a equals the limit as x approaches a of f at x minus f at a all over x minus a. So suppose the function is 2x squared minus 3, and my a value is 2. Okay, so f prime at 2, the derivative of f at 2, equals the limit as x approaches a of my function, just follow the notation, 2x squared minus 3 minus f at 2. A is 2. So, I can take that out now. A is 2. So, f at 2 would be 2 squared is 4 times 2 is 8. 8 minus 3 is 5. All over x minus 2. And this should lead to another indeterminate form. If I put in 2, square is 4 times 2 is 8. 8 minus 3 is 5. 5 minus 5 is 0. Over 0 means more work. So I'm just going to combine the tops to give me 2x squared minus 8 over x minus 2. I'll factor out a 2 and get x squared minus 4 over x minus 2. Notice I have not lost my limit notation. I'm going to factor out this to x minus 2 times x plus 2. These drop out. Replace the x with 2. 2 plus 2 is 4 times 2 is 8. So that means the slope of the tangent line at 2 is 8. So how would I actually find the tangent line? I need a slope and a point. So an x is 2. I know that y is 5. So the tangent line would be y minus 5 over x minus 2 equals 8. The normal line would be y minus 5 over x minus 2 equals negative 1/8. Okay? That's the alternate form for the derivative. Let me use that same form on one more example. Suppose we have f of x equals the square root of x, and a is equal to 3. So f prime at 3 would be equal to the limit as x approaches 3 of my function, which is root x, minus f at 3, which is root 3, all over x minus 3. Now, if you need to take the time to rewrite that out, feel free to do so. F prime at a equals the limit as x approaches a of f at x minus f at a all over x minus a. A is 3. So sometimes it helps people to write the formula out and then replace it. It's a limit problem, which we're very familiar with. I'll multiply by the conjugate. Actually, you could factor that as well. The tops will multiply out to give you x minus 3 over x minus 3 times root x plus root 3. These divide out, and I replace it. I get root 3 plus root 3, which is 1 over 2 root 3. So what would be this tangent line setup? It would be, well, when x is 3, y is root 3. So it's going to be y minus root 3 over x minus 3 equals 1 over 2 root 3. We can push through. This would be here 2 root 3 times y. Root 3 times root 3 is 3 times 2 is 6 equals x minus 3. So I'll get 2 root 3y equals x plus 3. I'll divide, and y would be 1 over 2 root of 3x plus 3 over 2 root of 3. The normal line would be the negative reciprocal, or negative 3 root of 2. Negative 2 root of 3, sorry. Negative 2 root of 3 would be the normal line setup. Okay, that's the alternate form. And one more actually gives us a function in return, so that if we want the slope at any x value, then this is the one that we will use. It is the f prime of x equals the limit as h goes to 0 of f at x plus h minus f at x all over h. So if f of x equals 2x squared minus 3x plus 1, I want f prime of x. This time, notice, look at this notation. This is the derivative of this function, which will be f prime, at x. That's what that means notationally. So I'm going to end up with this time the derivative as a function of x. I won't get a number. Before this were a number, it was a number, and it gave me the slope of the tangent line at that number, at that particular x. This is now going to give me it's going to give me a function in return. It's going to be something in terms of x, so that I can figure out the slope no matter what x is. So f prime of x equals the limit as h approaches 0 of 2 times x plus h squared minus 3 times x plus h plus 1 minus the function. And this is where students make errors. We forget to run the minus sign through. Minus 2x squared plus 3x minus 1 all over h. Notice what's interesting is, before I simplify and go any further, is it will be commonly asked of you to identify what the function was given the limit form. So in other words, I'm going to give you the limit form. You've got to recognize what the function is, and is there an a value. You can recognize that if you think about covering the x plus h, that's what you put in for x. This is your x part right here. So I could see that the function was 2x squared minus 3x plus 1. Or I know that when I go minus the function, that the function's over here in that part of the definition. But I ran the minus sign through, so everything would become the opposite. So this would become a 2x squared, a minus 3x, and a plus 1. Okay, we have to be able to recognize it in its other way. But in going forward and just simplifying this, I'm going to make this x squared plus 2xh plus h squared. I'm going to distribute and get 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 1 minus 2x squared plus 3x minus 1 all over h. Okay, some algebra that we're very familiar with. Everything without an h should drop out, and it does. And now if I take the limit as h goes to 0, I get 0 over 0. So I'm going to factor. And if I factor out an h, I have 4x plus 2h minus 3 all over h. Take the limit as h goes to 0. They divide out. 0 goes in for the h. And I'm left with 4x minus 3. So this means that if I want the slope at 2 for for the graph of that function. If I want the slope of the tangent at 2, f prime at 2 would be 4 times 2 minus 3. 8 minus 3 is 5. The normal line would be negative 1/5. If I want the slope at a, it would be 4a minus 3. The derivative is a function itself. The derivative is a function itself coming from the function. And we'll talk more about that coming up. So let's just play on some notation here. Suppose we were given the limit as h approaches 0 of the natural log of e plus h minus 1 all over h. And the directions here are to identify what the function is and what the a value is, or is a just x. So I'm giving it, we have to recognize that this is the definition of derivative. It's a limit of a difference quotient of that form, f at a plus h minus f at a all over h. It's a difference quotient, it's the limit of that difference quotient. The function is usually found by covering up that a plus h stuff. So I'll cover that up and think about replacing that with an x. So my function is the natural log of x. This is the a value, so a would be e. Another one, the limit as x approaches 2, or let's say pi, of the sine of x minus the sine of pi all over x minus pi. So this is the alternate form of derivative. It's x approaching the number, not the limit as h approaching 0. So here, the function in that form is that first piece. Remember, in that form, it's f at x minus f at a all over x minus a. So the function here is sine x, and the a value is pi. Okay? One more. What would this represent? The limit as h approaches 0 of, let's do, s of t plus h minus s of t all over h. This would be the difference, it's the limit of the difference quotient as h goes to 0. So it's the definition of derivative. It's the derivative of s, which would be s prime. And it's the derivative of s at t. So that would be s prime of t. If this were a 4, then it would be s prime at 4. Okay? Another one, which is one more, is the limit as h goes to 0 of f prime at a plus h minus f prime at a all over h. It's the limit of a difference quotient again. And it is the derivative of this function, which is f prime. So this is actually the derivative of the first derivative, which is your second derivative at a. So that actually represents f double prime at a. It's the limit of a difference quotient. It's the derivative of this function, which is f prime, and now you get f double prime.